So today what we're going to do is we're going to continue our look at triangles and properties of triangles, right? Last time we were here, we looked at Pythagorean Theorem, which was where you're talking about the sides of what kind of special triangle?
Right-angled triangle.
A right-angled triangle. Good, a right-angled triangle. Okay? If it's a right-angled triangle, you'll always know it because they'll say that the angle is 90 degrees, or they'll draw the little box in there. Usually they just draw the little box, yeah? Okay? If that's true, then the sides have certain properties, right? Remember that. First of all, if this is a right triangle, then this is A, this is B, and the slanted side has to be C. Do not confuse it, because the slanted side is a special side of a triangle, right? What's it called? It's got a funny name. The hypotenuse. And we're going to learn more about that today. Okay? All right. Now, can A and B be reversed?
Yes.
Absolutely. Who cares? And the formula, for looking for the sides, is what? A squared plus B squared. Excellent.
Adjacent or something.
We'll look at that today. Yeah. Okay? You're exactly right. Okay?
Opposite.
Yep.
That's it.
There you go. Okay. So remember, when you're looking for the sides, as long as you have two sides, you can plug them into the formula and then do the math and solve the equation and get the other side, right? Okay? What if you're always going to have to unsquare one of them, and how do you do that? Take the square root of it. Right. Good job. Okay? All right. Well, today what we're going to do is we're going to look at trigonometry. Some basic ideas of trigonometry.
What kind of math is this?
It's mathematics of triangles. Trigonometry.
Actually, she takes me to
Okay. All right, here we go, guys. So today what we're going to do is we're going to learn some basic rules that will help us find not only the missing side of a triangle, but we can also use it to find some things, find out about angles of triangles. So what we're going to look at is we're going to look at what are called the Trig Rules. Now, trigonometry, you can spell it out if you want to. I never do. Right? It means the same thing, of course. Now, what we have is I'm going to draw you a triangle, okay, and try to get it pretty exaggerated, right? Now, we already know that the long slanted side has a special name, right? It's called the hypotenuse. Good. Right? And we know that the sides A and B can be reversed, yeah? But this time, we're going to be very careful about which side we call what. The trig rules are going to involve making sure that you use very specific pieces at a very specific time. Now, we're also going to introduce one other symbol for you, and that is the idea of having an angle. And the symbol that you're going to see for any unknown angle is the Greek letter theta. Looks like a long oval with a line through it. Mine's a little too squat. Looks like an O. Okay. Yeah. Sororities and fraternities usually use Greek letters. Yeah. So, all right. So theta. Okay. So that's always going to be. It's always going to be some unknown angle, right? And the trig rules revolve around an angle.
Is it Greek?
Yes, it's Greek. All right, so all of trigonometry is actually Greek. Okay, so what we're going to do is we're going to look at some trig rules. But before I do that, I'm going to introduce you to an American Indian chief.
Okay.
Y'all don't do this, but in the States we do because we have American Indians. So in the States, we say that all you need to do to remember trig is to remember Chief Sohcahtoa. Right. Sounds like an Indian name, right? Toa.
So, I was really right.
I couldn't spell Toa. Oh, that's pretty sad. Yes, you should have seen this before in year 10, especially if you were in Miss Brader's class. I know you've seen it.
I was there.
Good.
I was Mr. Cat.
And then he didn't do the trig rules? I think they were just filling in at the end. So some of you did, some of you wouldn't have. All right? Now.
No, Mr. Cat wasn't in.
Okay. Guys, come on. Hold on. All right, here we go. So what we're going to do is we're going to talk about a few things. First of all, we know that we have an unknown angle, right? And everything about what we're going to do revolves around that angle and its location. Can we all agree on that?
Yeah.
Okay. You need to know a couple of things. You need to know opposite. If something is opposite something, then it's on the other side, yeah? Opposite it.
It's opposite the unknown angle.
No, it's opposite the unknown angle, right?
Yeah, that's right.
Yeah. So, I guess that's what you said, didn't
Yeah. Kind of.
it? Okay. I thought you said is opposite the unknown angle, not it's opposite the never mind. It's a matter of saying the right thing in the right.
Oh, did I say it like
no,
towards or something?
no, I heard it that way. Opposite means doesn't touch it. Right?
Doesn't touch what?
If it's opposite, it won't touch it. What do they all revolve around? The angle.
Oh, so like
So if this is the angle theta on this particular triangle, what is opposite? Side B.
Does it mean by doesn't touch it like these two touch it? In
Exactly.
But
Right?
doesn't it have like a little name?
Opposite. This is a little name.
There's hypotenuse.
Hypotenuse.
It doesn't, yeah, sides don't really have a name. All right? Well, they probably do, but I don't know them. Who cares? All right, here we go. The other little word that you need to know is the word adjacent. Adjacent means
Next to.
that it touches next to, right? It touches it. So it's right next to it. Okay? And we already know the H side because H is never going to change. H is always the what? Hypotenuse.
Wait, so which one's the adjacent on this photo? Is it C?
Not
C.
A.
The C looks like an A.
So let's just look here. So if I say hypotenuse, that's always that side, never changes, right? Doesn't matter. If I want the adjacent side for this one, here's my angle here, right?
It's A.
So which side is touching it?
C.
That's not a C, that's an A.
It kind of does.
Damn it.
But you meant that.
Yeah. And the opposite side is what? B.
Had.
Okay.
Which means it's cos. Good job.
Good job.
What? I think it was just a move. No, it's good.
Depends on what you want.
H, would it be sock?
Well, it depends on what you're working
depends
on.
on
You
what
can't
you're
really
at.
tell. It
You
depends
can't
on
tell
it depends on what you're looking for. Because if your unknown was there, then that tells you which one you're going to have. But it could be any of them right now, right? It could be any one of those things because they're all there. So now we want to talk about what the S, C, and the T are. Now those are some strange words that come from the Greek that you may not know. C stands for cosine. Okay? And again, remember, it's so katoa, so what's it got? Adjacent and what? Hypotenuse. Right? S stands for, I don't know why I didn't do them in order, the sine. Sin. You like to say sin? Okay, fine with that. And it's so opposite hypotenuse, right? And T stands for tangent. And T is what?
OA.
Okay? And what you're doing is you're going to be creating ratios with these.
You wrote OH before. Was that just me?
No, he did.
I did it backwards. It should have been, these should have been reversed, SOHCAHTOA. But,
I
okay.
have it written down that T was 08, but it should be wrong.
Oh, no, it's OA. I just had a capital A, but it looked funny. All right? They're ratios. In other words, a fraction. So if I say AH, ka, that really means A over H. You're always doing it as a ratio. So SOHCAHTOA, so would be opposite over what? Hypotenuse. Tangent would be what? Opposite over adjacent. So you can learn them with this phrases, that A and H, go O and H and O and A, but remember that they don't go side by side because that would mean you were multiplying them, right? It's really a ratio, so one over the other. It's a fraction that you make building those two. Okay? It's good? All right, so what we're going to do is we're just going to go through and look in your book at a couple of these so that we can make sure that we can find the right trig ratio. Okay? So I called these earlier the trig rules, but they're also known as the trig ratios. And the reason for that is they're always a ratio, which just means a fraction. A comparison using a fraction is what ratio means. So comparing one number to another using a fraction. And what does that fraction bar always indicate to do? Divide. So keep that in mind as we go. That the trig ratios can be used for other things other than right angles. It's not always right angles. But of course we're studying right angle triangles, so the ones we use are always going to be right angles. So it's important that you know that the right angle can be the angle, your reference angle, but you do know it, even though we usually use theta as an unknown. If you're talking about the one with the square in it, you do know that angle. What is it? 90 degrees. It never changes. The angle with the square in it never changes. So here we go. If our theta is here in this far right-hand side, then the angle opposite is the O, the opposite. The slanted side is always the hypotenuse, never changes, and the one right next to it is called the adjacent. Okay? So what we're going to do first is just label a few of them, H, O, and A. So let's look at number 2. 19. So let's look at number 2 together. Remember, we always do the evens together and the odds you're off to with the homework. So here is my reference angle, right? Well, first of all, H should always be first, and because it's always easiest. Which one's H? The long slanted side, the hypotenuse, right? So that means that the one straight across from it is the what?
Opposite.
And the one touching it is called the adjacent. So real rocket science going on here, right, guys? Okay. So here's my reference angle. It's called a reference angle because we're referring to it to create the rest of the things. That's why I call it that all the time, so don't worry about it if you don't. The angle theta is there, so the long slanted side is the hypotenuse. The one I just drawn an arrow to is the opposite, and the one right next to it's called the adjacent. Here's my theta. Here's the hypotenuse. The one across from it is the opposite. The one next to it is the adjacent. Sound good? So just remember, doesn't touch it, it's opposite. Touches it, it's adjacent, unless it's the slanted one, which is the hypotenuse. Ready? Okay, so now, we talked about SOHCAHTOA, sine, cosine, and tangent. And again, they simply relate to those ratios. So sine of theta is the O, cosine of theta is the A, tan of theta is OA, right? Okay. So here we go. If we know pieces of the triangle, we can use those trig rules or trig ratios to be able to find other sides as well as the angles. We're going to concentrate first on just finding the sides, but then later we'll talk about the angles. Okay? And you're just solving basic equations, but you always need to make sure that you have the right stuff in the right place. So look at this one. We're going to calculate the length marked x. So in other words, we're trying to find the length of that side. Okay? And so we have our angle, and in this time we know the angle, right? So we're going to label the problem with A, O, and H. So first of all, the slanted side is what?
H.
Hypotenuse. The one across from it is O, and the one next to it is A. Yeah? Now, since I know the hypotenuse, that's not going to be part of my calculation as far as the unknown parts, yeah? I need to just label the unknown parts. So we have the opposite side and the adjacent side are my unknowns. So always make sure what it is you're looking for. Because we have this one, right? Okay. Now, but in order to determine which trig rule to use, I have to think about the one I'm looking for as well as what I'm already given. Because I can't have two unknowns, can I? The unknowns that I can solve for in an equation is what? 1. So in this case, if the angle is here, do I know the hypotenuse?
Yes.
And do I know the opposite? Sort of. It's called x. But which one do I know nothing about? So that means I can't use that side in my calculations. Does that make sense? So anytime you're trying to decide which rule to use, throw out the one that has no information at all, right? And as a general rule. Now, there are going to be times when we're going to have to make a decision based on something else. But I know the angle, right? Theta. I know the opposite. Well, I know something to call it, right? And I know the exact value of the hypotenuse. So if I know opposite and hypotenuse, that corresponds to which trig ratio? The sine. Yeah? You can call it sin if you want to. It's really sine, even though it's abbreviated S-I-N. And sine of theta is simply the opposite over the hypotenuse. All right? So just find the one that you know, the one that has no information at all, toss it out, and then you're going to use the other two. Does that make sense? Yeah. Okay. Now, all I need to do is replace the stuff I know with the things I don't know. So, replacing theta, what is the angle I have here? 41 degrees. So, I know that that's going to be the sine of 41. Equals, opposite is what in this case? The x over hypotenuse, which is what in this case? 17. Now I have enough information to be able to solve this equation.
How do you do it on the calculator?
That is... First thing I need to do is clear the fractions. To clear the fractions, I need to multiply by the common denominator. Guys, so what is the only denominator up there?
Sorry.
Well, but yes, but we replace it with a letter. So 17. So I'm just going to multiply both sides by 17.
No. This is algebra old
All right. Well, if I take 17 times the sine of 41, I don't even know what the sine of 41 is. So I'm just going to write it as 17 sine 41. Over here, the 17 in the top and the 17 in the bottom are going to eliminate each other. What does that leave me with on this side? X. Is my x by itself? Yes. Guys, is it but? Do I know what number it represents? No, but I know it's 17 times the sine of 41.
When you say sine of 41, what is that?
That means you're just going to plug into your calculator the sine of 41. So you should have all three trig functions, and you actually have their reciprocals on your calculator as well. But if you find sine of 41 and plug that into your calculator, then take that answer times what? 17, and that'll give you your number. So somebody found your sine button? So let's look at the second example. Again, here's our angle. Everything revolves around the angle. The hypotenuse is the slanted side. That means that's the opposite, and that's the adjacent side. Yes? So I don't know anything about the adjacent side, so I'm not using it, right? I'm looking for the hypotenuse. I have the opposite, so that is a what? Sine. Opposite and hypotenuse. The only combination you can get is sine. So, right? Now, just plugging in the numbers, we have the sine of what angle? 41. And technically, you're never supposed to write that without degrees, by the way. Okay? And we have the opposite, which is what? 15 over the hypotenuse, which we're calling x. Okay? Right now, I have divide by x. I need to get rid of that. What's the opposite to divide by x? Multiply by x. So I'm just going to do that to both sides, which is going to give me x times the sine of 41 degrees equals what? 15. Now remember, I'm trying to get the x by itself. Is it by itself? No. How is it connected to the sine? What operation? So I'm simply going to divide both sides by the sine of 41 degrees. And now I'm ready to go to the calculator. Okay? Because over here they subtract away, which leaves me just my x. So I'm going to put 15 divided by, and then you have to use brackets. I don't know if you have to use brackets on this because it's sine of 41. So try it without the brackets and see what happens with it. It should know, the way you know which trig rule or trig ratio to use is by looking at what you have and what you're looking for. So just like here, we had opposite and hypotenuse. The only thing that can go with is the sine, right? What if I had opposite and adjacent?
Oh, that's tangent.
That's the tangent, exactly. So you'd have to use the tangent function to do that, right? What if I had adjacent and hypotenuse? That means that, well, that's cosine, right? So I'm going to have to use the cosine rule. So katoa, right? Okay? So you can know which ones, again, by simply eliminating the one you don't know anything about, and you're using the other two. Okay? So what you're going to do is, guys, what we're going to do is, we're going to do some of these where you're looking for the sine. So what I'm looking for the side, and then next time we're going to use the same rules to be able to find unknown angles. So what I want you to do is simply go through some of these and practice some of them.
Okay.
All right? So let's find. So here you go. You're going to do evens and odds, so all of them. So all on pages 30 and 31. Right? And now it's a mixture of all three rules. So if you want to practice some of the rules separately first, you certainly can. Okay? There you go.